Hi guys, this is Ben, and I'm about to do the P3 for April 18th. This is enzymatic elimination. Carboxyesterase enzymes form hemiketals and alpha-ketooxime substrates. These intermediates, boxes 1A through 1C, can then undergo E2 elimination reactions within the active site. E2 plus E2 refers to the idea that two double bonds are formed in a single step via two connected eliminations. The hemiketal substrate must be able to adopt a conformation conducive to E2 elimination. Your task for this problem is to choose the hemiketal conformation from boxes 1A through 1C that is best for E2 elimination. Erase the other two incorrect pathways and draw curved arrows depicting electron flow for the correct elimination pathway. Alright, so let's open up our Sketcher window. So we have these three options, and we want to look at the one that's conducive to elimination. So the electron flow is going to go something like this. We're going to bump this down. This is going to bump off and go on to here, which then would bump this off. So that's the electron flow. Now we got to figure out which one represents these conformations. So this looks okay. Alright, so this looks okay in terms of here. And then this is going to be linear, so it doesn't really matter. And that'll bump off. Okay, so the N matters because it needs to be able to accept the double bond. So the NO orbital needs to be able to be bumped out. So yeah, so this looks like right because they need to be anti to each other, and this one we can rule out because okay, I see, this is over here, and okay, so it looks like A should be right, so I'm going to erase all these. A should be right, and then the electron flow, it's a general base assisted, so this comes over here and grabs the hydrogen, that bumps this off onto there, that goes onto the double bond, and that bumps off. So let's see. See the products that it has formed. Oh, this goes down there. Okay, let's try that. Yep, correct. I had a minute and 30 minutes remaining. Alright, so just a recap really quick. So the reason why these wouldn't work is because they all need to be anti to each other because it's an E2 elimination. So we know that this bond right here is gonna make a double bond. Well, it needs to make a pi bond with the anti bond that we want to bump off. So this is the conformation that we want for an anti well, as you see, we're going to compare all these hydrogens. So this guy was over here. These are syn to each other. This bond and this bond are syn to each other. These are the only two that bond is anti to each other. So that's the reason. And then it bumps this bond out in an E2 fashion, and it bumps onto the nitrogen to form our nitrile product. And so it bumps off, and it needs to fill into the pi orbital of this leaving group, our oxygen phenyl. And so they need to as well be E2 to each other. So bumps in, this guy has to be facing in the anti position. In this one over here, they are syn to each other, so that won't work. So that's why A was correct, and then it's all about using the general base. Hope this was helpful, and I'll catch you guys later. Thanks.